I, Christine Witkowski, are all really excited to share with you our perspectives from our different disciplines on this really, really important topic of global climate change. It's a subject that all three of us are passionately interested in, and we come at it from different angles given our disciplinary expertise. And we want to share some of those nuances with us. So the way we're going to start is we'll each introduce ourselves, and then we're going to jump into a brief introduction about the science of global climate change presented by Dr. Graviton. So I'm Christine Witkowski. I teach sociology and geography in the Department of Social Science, Behavioral Sciences, although I'm only representing sociology today since Brian is representing geography. When we study the issue of global climate change from a sociological perspective, we really have a heightened emphasis on understanding how is it that well, first of all, what are the effects on humans at all levels in terms of global climate change? So how does it affect us at the micro level in our families, in our communities? How does it affect us at the macro level in terms of the global interrelations? So that would be something that a sociologist would be really interested in. When we try and understand where what the causes of global climate change are, we're really interested in studying the impact of culture, social structures, and social institutions on bringing about this massive global problem, and in then understanding what the levers of change are. How can we adjust the culture? How can we adjust the social structure and the social institutions so that we can more effectively bring about solutions to global climate change? And how can we understand the impediments to those changes? So that's the perspective that I'll bring to the table today. And I'll let Dr. Kimmel introduce himself, and then Dr. Graviton.
Thanks, Christine. The political science perspective on climate change focuses in a few different areas. Number one is the legal perspective, right? So one example of that would be, what about your property rights? So let's say you own a house near the coast, right? And in 50 years, beach or ocean levels are higher than they were. What happens to your property, right? Do you still own that land? Do you have any rights to hopefully move somewhere else? Who owes you what, right? For people who live on the coast today or live near the coast, they're going to want people to try to protect their property rights. Like this is something that's been going on in the Outer Banks of North Carolina as just one of many examples. And so erosion is destroying a number of houses there. And people that live in Avon, for example, they recently were talking about this, having a property tax increase to pay for beach nourishment, to take sand from under the ocean and put it out on the beach, as a losing battle against rising oceans and just natural erosion on the ocean. So who pays for all that, right? It's very expensive to do. The political aspects of it are important as well, right? So some of these responses are going to require new laws, and some of them, and the big debates have been around, who pays for it, who's punished, right? Whose life has to change, what's fair, what's not, right? And that's been a big, big problem in trying to figure out how to advance and how to deal with this emerging and continuing problem. And then also the international relations perspective is looking at things like war and peace, right? So just as one example, if you think about some of the predictions that are looking way into the future, where you're looking at a future scenario where arable lands, which is good for farming, has shifted up in the northern hemisphere from the US perspective up to Canada, right? So now you have a situation where a country like the United States is extremely powerful militarily, but is having its arable land shift away from it. So you can imagine future politicians in the US say, well, we're going to need that Canadian land, right? And that increases the likelihood of war and conflict. That is just one example of endless sorts of problems that can arise from this. And so that's the political science perspective on it. Generally, there's a lot more to it, obviously. But Dr. Graviton can take us forward on the scientific component.
All right, thanks, y'all. So as a geographer, we like to have kind of one foot in the social sciences and one foot in the physical sciences. So my goal here is to spend the next 10, 12 minutes just kind of laying the groundwork for the global science behind climate change and the aspects that are human induced, to kind of lay the groundwork for the discussion where we'll get some of the more social science insights that TJ and Christine have mentioned here. So geographers.
Brian, let me interrupt for one
Yeah,
second.
sure.
I neglected to introduce our department chair, Lloyd Pilkington, Dr. Lloyd Pilkington. So I just wanted to let you guys know who else was in the panel here, since you'll be seeing his face. So he is our esteemed department chair.
Thank you, Christine. It's just a pleasure to be here with you all. I'm really looking forward to this topic and the great information you're going to share. Thank you.
All right, so as a geographer, we like to think globally and we like to think about different systems. And so the way that we study climate is to sort of look at the Earth holistically and try to understand how these different components of Earth's as a total system interact with one another. What are the feedbacks? What are the relationships between these things? And there are two really simple Earth system science concepts that we can introduce here that we can carry with us, so that you know some of the patterns to look for when we look at some of the climate graphs and models that we'll see today. So the first is, when we look at a system like climate or anything else on our planet, we can recognize these periods of steady state equilibrium. And the idea here is that we've got a period of time where we see fluctuation with different variables, but we can identify a relatively stable average through that period of time. So, if we sort of use this really abstracted diagram here and think about climate, right? If climate is sort of looking at tens of thousands of years, hundreds of years, the static you see here, or the rise and fall, is sort of warm years, cool years, wet years, dry years, but nonetheless there's a range of possibilities, and we can draw that steady state average in between there. The other thing to recognize with climate is that it also exhibits really dynamic change as well. And so you see here this image of dynamic equilibrium, which suggests that we've got variation around that stable average, right? And then we see a trend emerge around that average. And at some point, there's a threshold that gets crossed. And so this could happen sort of gradually, where that system's stability gets undermined and it becomes a bit more chaotic and it's unsustainable. Or it could be, a singular event that causes a major change in one variable. And then that system really changes. It changes to some kind of new condition, something quite different from what we saw before. And so as we look at some of the climate data here, I encourage you to sort of look for these periods of steady state, these periods of dynamic change, and keep these kinds of models in mind. The first image here is a big one. It goes back 70 million years. We're just looking at one variable, so we're just looking at temperature averages, and what you see here are those types of steady state and dynamic change, right? So, for example, from 30 to about 20 million years ago, you've got this period of relative stability and steady states. Whereas if you go back to sort of 50 million years here, you see this big change, this big warming trend, this big cooling trend sort of on either side of 50 million years ago. something to keep in mind when we look at these long-term data sets is to remember where we fit in. And so anatomically modern humans, they don't come into the picture until about here. So this kind of long range data can do a lot for us in terms of understanding our current condition. It tells us that all of this change back here is due to natural causes. And so we can look at those natural causes in the distant past and begin to understand what might be some of the natural fluctuations we could expect in our present. And then, of course, that allows us to kind of filter out the natural change and then understand the human-induced change in what's happening right now. A couple of the things you might notice, I mean, one is that the temperature has been much warmer than it is now. So the reason our current trend is alarming is not because we're the warmest we've ever been, but because of the rate of change and the difficulty in us adapting as a civilization to that change. And also keep in mind that when you get back here, right, 55 million years and prior, you know, we're talking about a period of extinction of dinosaurs. We're talking about the rise of the mammals. We're talking about major meteor impacts and volcanically active planet where the whole globe would look more like Yellowstone National Park does today. So very different world. When we look at those past fluctuations and try to understand what's happening, there are a lot of different components to that natural change. I've got here sort of the four big ones that we use to account for those thresholds, those warming periods, those cooling periods in the past. And so continental landmass position is really critical because it changes the way that ocean currents flow, and that influences how much heat and how much evaporation is happening in different parts of the globe. Axial tilt, the Earth actually does wobble on its tilt some, and that changes the amount of solar radiation that's received at different latitudes. There's solar variability and volcanic activity, which is what you're seeing here in the images. Notice that when we're talking about natural change and continental land masses, we're talking about millions of years, so very long time scales. Axial tilt, thousands of years, pretty long still. Solar variability is something that we can start to look at changes over decades. And so what you're seeing on the left is a period of high solar activity with these sunspots, and then a period of low solar activity. So this is 2000 and 2017. So decades or a little longer cycles of more or less solar radiation. And what you're seeing down here is volcanic activity. This is the eruption of Mount Pinatubo in 1991, and Mount Pinatubo is in the Philippines, so it's about here. And what you're seeing in the brown and orange is all of the soot and the ash that's been ejected from the volcano and how it's been swept up in atmospheric currents that then carry that soot and ash across the Earth. So this is a few months after the eruption. You get this global scale impact, and that soot and ash actually reflects the solar rays. So we get these short-term periods of cooling associated with volcanic activity, as well as greenhouse gases that are emitted that then have a little bit longer lasting power. All right, so what does all this mean, right? Why do we look at these long time scales? Why do we need to know about natural variability? Well, we need to know about these things so that we can understand what is happening to us now in the present. And you know, the takeaway here for our current trend is that the rate of change and the extent of change that we see are inconsistent with natural variation. The graph here might look a little messy. It's actually relatively simple. I mean, what you have are all of these different colored lines, and these are scientific data that's compiled by various different agencies. NOAA, National Oceanic Atmospheric Administration here in the US is a notable contributor to this data set. And so you see, people talk about, variation within the science, right? People seeing different things at different parts of the globe, different institutions making different declarations. And you see that there is some variability here, but the trend is pretty tight. I mean, the variability between these different data sets, those trends are still relatively intact, and most certainly the overall trend is intact. What this is showing is the change in temperature. What we can do then is, if we know this is what's happening, right, a change in temperature, you see this data set starts in 1880, which is when we started to continuously monitor these things with modern scientific instruments. We can go back much further using things like fossil records and ice core data and speleothem samples and tree rings and all sorts of other things. Why I showed you this is so that I could show you this graph on the right, which shows us that same curve, right? That same trend of what's happening, right? What's actually occurring. And this brings us up to 2020. The thing that's added here is the blue line. And the blue line is what these scientific agencies have determined are the natural cycles and the natural pull on Earth's climate system. And so if we were only accounting for natural factors, if we only measured volcanic eruptions and sunspot cycles and the rest, we would expect to see some warming, cooling, warming, cooling, warming, cooling, and then the recent trend of moderate warming within, less than 1/4 of a degree. Now, what you should notice here is the gap, right? The gap between sort of the natural cycle, that blue line, and then the multicolored lines up here. And so how we make up for the difference is that, yes, there is some natural variation that's causing warming and cooling, but the warming trends that we actually observe, that we actually see, the human component is what magnifies that change. I'm probably not telling you anything you don't already know here, but what are the causes of this, right? Anthropogenic emissions, human-caused emissions that make up that difference between natural change and what we actually see happening in our climate. And there are lots of different sources of anthropogenic emissions. I only included a couple here, sort of 3 big ones: carbon dioxide, methane, nitrous oxide. You see all 3 of those gases on the graph here, and we're going back 2,000 years now on that image, showing the variability, right, the steady state, and then the crossing of a threshold here since the Industrial Revolution. The sources of these you see on the left, some familiar. I mean, everybody knows that fossil fuels are a major contributor here, but there are lots of other things you might not think about. So, for example, cement production. And when you think about urbanization and the global process of that, this is a major component. Deforestation, removing the Earth's ability to absorb that CO2 into vegetative matter. And then mining, which hits methane pockets and also releases other greenhouse gases. Livestock and fires also contributing to methane, as well as plant decay. Fertilizers, water treatment plants. I mean, all of these sort of different aspects of our modern civilization that improve our lives and improve our food security in some ways, but also cause these feedbacks within Earth's climate system that are really concerning.
Brian, do you mind if I ask you a question as you're going through this?
Yeah, sure. I've just got a couple more slides, but go ahead if it's something.
No, go ahead. I'll ask you when you're done. That's good.
Okay. Yeah, thanks, TJ. So, I probably don't need to tell you, again, sort of what's happening here. I mean, I think we're all aware of this. So, we're seeing rising temperatures, and this is a time series image from NASA showing warming and cooling spots on the globe starting in 1880. And so you see, that the system is dynamic, right? There's warm years, there's cool years. But what we see is this accelerating feedback and pace of change after World War II, where we start to see more warming along more spots of the globe, leading us into the present. And you can see here that the effect is not uniform, right? The Arctic, for example, is warming at a much faster rate than other portions of the globe are. And we've even got these spots of cooling here, like this one in the North Atlantic. And the reason for this variation is because of the feedback. So the overall trend is rising temperatures. And those rising temperatures then cause responses from other aspects of our system. And so we get stronger storms, we get more wildfires, we get longer droughts, higher floods. Another way to think about this is when you see more warming up here, it's because we have warmer temperatures causing ice melt, which then exposes new soil, which then reduces the reflective quality of the Arctic. And so those soils that have normally been protected, I guess you could say, from the ice, are now absorbing that energy and re-radiating it as heat. And so you get much more dramatic warming trends there in the Arctic because the change is much more dramatic. And then looking at something like this here, where you've got this cool spot, this is from all of that cold water coming in from the glaciers in Greenland and further north, and all that cold water rushing into the North Atlantic, where it gets trapped in this circular gyre pattern where the ocean currents kind of pool that cool water together. Of course, that won't last forever because those glaciers won't last forever either. Here's the bottom line, right, from all of what I'm talking about here, which is that the climate system is crossing a threshold, right? And it's crossed thresholds in the past. That dynamic change we can see in the geologic record. But as it crosses thresholds that are unprecedented in human history, right, the question becomes, what can we do to sort of adapt to or mitigate these kinds of changes? And to borrow sort of a line of thought from Carl Sagan, or if you know him, the famous astronomer, when the Voyager probe was leaving our solar system and it looked back and took a picture of Earth, Sagan says that, looking at that pale blue dot floating out in space, you've got to remember that everyone you've ever known, everyone you've ever read about, every event that's ever happened, right, that we're aware of, happened on that blue dot. And if we can sort of translate that to what we're seeing here, we're looking at CO2, and CO2, one of those greenhouse gases that traps heat. So the connection there between CO2 and temperature, we've got rise and fall and rise and fall around a steady average. We pop up here, anatomically modern Homo sapiens. We become agricultural about here. We settle down. We start to build our civilizations. We become industrial about here. And so every human that you've ever known, every human you've ever read about, every human fossil we've ever uncovered, every human civilization that's ever existed, right, happening within these kinds of boundaries, warming and cooling. And here we are, right, passing that 300 parts per million of CO2 in the latter half of the 20th century, and then passing that 400 parts per million of CO2 here in the 20th century. And so this is kind of the situation we're faced with. These are the trends that we're uncovering. I'm happy to answer questions kind of as we go, if we want to jump back to some of the scientific stuff. Maybe TJ has something to ask me first before we kind of move into more of the really distinct social science territory here.
I want to say to all the attendees, if you have questions, put them into the chat, and we'll be happy to try to get to as many as we can while we're talking about it. We're happy to work with your interests and concerns. One of the questions we got from the chat so far already was, what role does the sun play with climate change, and how does cement contribute to CO2 emissions? Some students haven't heard that before.
Yeah, I mean, so with the sun, I mean, obviously the basics of why our planet is warm and habitable, right, is that solar radiation comes in, our atmosphere allows it through, and then that heat gets trapped by greenhouse gases, right? So that's sort of just the basics of the greenhouse effect. In terms of the sun sort of changing our climate, when I talked about those sunspot cycles, we think of the sun as kind of this stable emitter of radiation, and it is, thankfully, right? But we have these periods of activity, those sunspots that I showed you, and basically those are storms on the surface of the sun that emit more solar radiation. And so when we can see some of the natural fluctuations are due to more solar radiation that's headed towards the planet to begin with, and so you've got a higher input of solar radiation, and therefore you can have some additional warming in the short term. The cement production, I mean, I don't know all the particulars of sort of what goes into cement and how it's made and so forth, but essentially it's a process that emits CO2 as we make cement, as we lay cement, as it dries and so forth. So the general idea there is that building cities and construction can be a source of these greenhouse gases.
I had a question sort of along those same lines. So just taking this from the perspective of someone who might be a little bit skeptical about part of this argument, right? So the evidence is overwhelming that the temperatures are warming, right? That much is clear. The debate has been the degree to which it's human caused versus more natural sort of things, which you sort of dealt with when you were talking about it. But as I was looking at the chart, I was curious about, since the Industrial Revolution started in the 1860s, why did it take until the 1980s and 90s before you really started to see that temperature switch up, right? Since the Industrial Revolution had been going on for well over a century. And sort of a larger question, which ties into social science, and one of the questions we deal with is, do you have, or does anybody have any causal evidence, right? It seems like there's a lot of corollary evidence here, but is there any sort of definitive evidence of causation that we know that because of this is definitely happening, not that they're just happening at the same time and not causing one another?
Right. So, I mean, those are big questions. And the first one's kind of simple in the sense that when we look at really long time scales, like if you look at CO2 over hundreds of thousands of years, and then you look at temperature and you look at the correlation, it's hard to see the relationship between the two. When you start to look at decades, though, you see that there's a lag. So the CO2 gets added to the atmosphere, the amount of CO2 rises, but the temperature response is delayed somewhat. And the easiest way to kind of bring this down to the individual level is to think about the course of a day. And so, you wake up in the morning, the sun rises, the temperature rises over the course of the day, but at noon is when we have the highest levels of solar radiation hitting the surface of the earth, right? You look overhead, the sun is, if you're at the equator or at the Tropic of Cancer, it's directly overhead. But the warming of the atmosphere doesn't actually happen until the afternoon. So the afternoon becomes the warmer period of the day. And so if you can kind of take that small time scale, right? Lots of solar radiation at noon, greenhouse gases begin to trap it, and then you see the temperature reach its peak at 3:30 or 4. If you can take that small time scale and sort of think about it on decades, right? If the Industrial Revolution is at noon, right, and then the warming is sort of in the afternoon, if that makes sense. Yeah.
I guess.
Yeah, I mean, there's a lag in the response. There's a lag in the response of temperature. So you get the greenhouse gases, we begin to trap more heat, but the overall trend doesn't really pick up and sort of take hold until later. Yeah.
So if that's true,
Yeah.
then everything we do today won't impact anything for 50 years, 100 years? Is that what that means?
Well,
theory.
sort of. I mean, it's also about an accumulation too, because so you know using the Industrial Revolution as a time point. And so CO2 also stays. It has a residence time in the atmosphere. So a residence time is sort of how long does that gas stay in the atmosphere once it's emitted, and the residence time for CO2 can be up to 200 years. So the warming that we have right now is not just because of CO2 that China's emitted since 1960, but it's also because of CO2 that Europe emitted in 1800. Does that make sense? And so those gases in the early phase of the Industrial Revolution, they get up there, they stay there, we continue to add, and those early gases still contribute to warming on the long term. Yeah.
Gotcha.
So I'm going to be the rude one to move us along just a tiny bit to our next topic, which is about current impacts. So in what ways is global climate change going to affect humans? And I want to start this out by addressing a question that one of our attendees asked, which is how long do we have, right? How long before the Earth becomes uninhabitable to humans? And I will let Brian chime in here, but I would say that we have no definitive answer to that question, right? It really depends on how we respond to the problem. It also depends on how we, what kinds of technological innovations we're able to come up with and implement in order to be able to adapt to the climate change that we're experiencing. I think that humans are incredibly innovative, and we can come up with incredibly cool solutions to help us persist despite a rising climate or rising temperature. But the problem is other species won't necessarily adapt at a rate in order to survive, right? Species have evolved over millions of years to a certain set of circumstances, and they can't use cultural adaptations the way humans can to adapt to rising temperature on the planet and to all the erratic conditions that we're going to experience. And so we may ultimately lose a lot of species, and we don't know what the keystone species are that we rely on for our survival. And so if we knock out the wrong species through our changing climate, we could be in a heap of trouble. Do you want to add to that, Brian?
Yeah, I think that question of adaptation is a big one, and we talked a little bit about this in our discussions, kind of as we formed this panel. We always jump to these like doomsday scenarios, like New York's underwater and the Earth is uninhabitable, like as a whole, right? The sort of Mad Max kind of hellscape, right, is sort of where our minds go. And I think that if those are the kinds of things that kind of draw you into this, then that's great. But what I would encourage us to do is to think about what's happening right now. Mm-hmm. And who is vulnerable and in what ways, right? And so, let's bring it right here to Columbia, right? We had a historic flood in 2015. Hurricanes happen; they hit South Carolina. They're caused by natural cycles. But what we've seen is bigger storms. We've seen slower moving storms. And that's what we got in 2015. We got Hurricane Matthew. It came in, it sat on Columbia, it rained for days. And, the question should be not what makes sort of Earth uninhabitable, but, in our case, can we provide clean drinking water at the plant on the Broad River if we know we're going to get these kinds of floods? And if you go down to Riverfront Park, you can see this right now. I mean, we've got a 5-year project that's nowhere near done. where they're reinforcing the walls along the river. They're building new water capture systems so that we don't lose clean water for 2 weeks or a month in the city when these kinds of events occur. And so, you know, maybe we can talk about this a little more from sort of sociology and political science, right? But I think this theme of a risk is really important, right? Who's at risk from what? Who's most vulnerable? Why is that occurring? TJ brought up sort of coastlines earlier, right? And so that's kind of a good example to maybe go off of if we want to talk a little bit more about this.
Well, Brian, sort of building off what you were talking about, I was just looking up one of the articles that covered rebuilding the Riverwalk Park after the 2015 flood. And just the Casey part of it, it took 11 months and cost $1.4 million. And theoretically, they've rebuilt it. And I know some of the FEMA requirements in order to get federal money were that you'd have to rebuild it to survive something stronger. But you know, if you have more events like that, right, those unusual weather events, not the doomsday scenarios that Mad Max kind of world, but just really freak floods that you didn't used to have, how much are we going to really want to keep rebuilding, you know, in the same places over and over and over again, when that's how many millions of dollars are we as a country, as a government, city, state, local, federal levels, how much are we willing to pay for that? You know, and those are things that people really aren't really facing yet, right? The impact of the fact that if we want to keep living like we're living and temperatures keep going up, right? It doesn't mean we're going to have a Mad Max world. It means that we're going to have more of these freak things. And how do we keep, and who's going to pay for that, right? Who pays to recover from tornadoes? Who pays to recover from floods and hurricanes?
Right.
You know, it raises those larger questions.
Yeah, and this, I mean, one thing you're getting at, or a term I'd sort of put on it is resilience, right? Is, you know, how resilient are we? How resilient can we be? And, you know, there's a big difference between the United States kind of building seawalls in Miami or New Orleans, between, you know, sort of the country of Bangladesh, which is mostly below or at sea level, where you've got the majority of the population living on less than $2 per day. And, you know, the most expensive thing they make is shirts, is t-shirts, right? And, you know, the resilience of certain places around the world is really something to give some thought to. And are we prepared to have, you know, millions of climate refugees, which we're already starting to see from the Pacific, when we can't even accommodate people that are migrating from war zones in the Middle East to begin with, right? And so the resiliency of sort of different places, I think, is something that's on my mind. And that, to me, that's really frightening, right? Thinking about sort of the global flows of people and risk.
And that's something that is of very heightened interest to me as a sociologist and a geographer. And it really helps maybe for us to step back and look at some of the immediate impacts for those who aren't familiar with this. So as we have this rising average temperature on the planet, it leads to more erratic climate events. So we have a greater likelihood of droughts. We have more extreme droughts. We have extreme weather events like floods and hurricanes, more tornadoes, sea level rises, with not just with hurricanes, but also just storm surges, right? And so all kinds of human infrastructure and habitation is destroyed in the process of being hit by these kinds of extreme weather events. Agriculture ends up being disrupted, so that crops that we've become acclimated to using in certain places where we're accustomed to having certain temperatures to go along with those soils are suddenly more vulnerable because it's either hotter or colder because of the erratic weather. And so we can't be as agriculturally productive. And so the thing that's really critical for all of our attendees to understand is people around the world are disproportionately able to adapt to these circumstances. And this sort of goes with what Brian was saying, we in the developed world have the resources to be able to remediate the effects to a large extent of these kinds of these extreme climate events and the fallout from it. We can rebuild. We can come up with methods of dealing with the problems, but the people in the moderately developed world are less able to do that, and the people in the least developed countries of the world are going to be disproportionately vulnerable to the effects of global climate change. And there's dispute about this next statement, but there's a great likelihood that we're going to see more climate refugees as a consequence of global climate change than the current number of political and economic refugees. So the likelihood of us having those people in developed countries of having to deal with this massive influx of climate refugees is something that's really alarming to political leaders and citizens in developed countries, because we're already worried about the influx of refugees. And the thought of trying to be able to take in more refugees is really, really a daunting prospect. So I think that some of the imperative in understanding the problems is to see it's not just a long-term problem. This isn't something that's just going to affect humans 100 years from now. We're already being impacted. It's affecting us economically. It's affecting us in terms of the stability of cities, the stability of communities, the stability of families in the developed world, but in the less developed world to an even greater extent.
Yeah, I think like Christine's saying, you know, and this is one of my big themes here, right, is bringing it to the present. And so you think about all the people that have been displaced by you know, Hurricane Harvey in Houston, or all the people that came to Columbia from Charleston when we have a hurricane evacuation. You know, you think about those kinds of themes, and then think about conflicts that get amplified by climate change. So there are connections between the drought in East Africa and the conflict in South Sudan. When we had the Arab Spring in 2011, you know, there were lots of different reasons for that, but one of them was that grain prices had risen because we had droughts in Africa. And so there were these additional sort of economic pressures that kind of caused people to find some way to sort of deal with that additional stress. On the flip side, there are some places that really stand to benefit from climate change, right? I mean, if I'm Putin and I'm looking out at the map of the Russian Federation, and I'm looking at all this land that's covered with ice or unarable for some reason, and I'm seeing that my arable land is going to increase, and that my sea routes across the Arctic Ocean are going to increase, right? You might not be as concerned about these kinds of things. And, you know, I'm being a little flip about it, but still, I mean, there is a need to recognize that all places are not being affected in the same kinds of ways, and some places potentially could benefit and already start to benefit. You know, the Northwest Passage is open, meaning that you can take a container ship across the Arctic Ocean. You didn't used to be able to, and China's using it, and Russia's using it, and the US Navy is worried about it, and Canada's worried about it. These are things that are going on right now.
TJ, do you want to talk a little bit about the kinds of conflicts that have arisen over the Arctic? Is that something you can speak to or not?
I'm not super well versed on that. I know that is something that is a major point of concern going forward, because, you know, for so long that was an area that you didn't have to worry about from the Canadian and the United States perspective, because it was frozen, right? And it was not really possible to cross in any way with large numbers of troops, for example, or with a navy. And so that could change, or it will change if that continues, all that melting continues to occur. It will change the geopolitical dynamics in that part of the world dramatically, from where there's basically no impact today to potentially enormous impacts. But something I wanted to sort of speak on and to bring in a question from the chat. was going back to what you were talking about, the present day impacts. And so one of the examples of this we're seeing with a lot of farmers is that we'll have like a really unusually warm spring, right? This happened a few years ago where it was really, really nice, I think 2017. And then we had this huge cold snap come through. And in South Carolina and Georgia, basically all of the peaches died on the vine, right?
This may actually happen tonight as we speak, because
Yeah.
we're going to have a freeze. Yeah,
Yeah, I don't think it's supposed to be quite cold enough tonight.
it is here in where we grow a lot of peaches in South Carolina, in the counties out near my way. We're supposed to get down to 28 degrees. So there's frost warning. So go ahead with what you were saying, though.
Yeah, I mean, that's just another example where that wasn't nearly as much of a concern. It could happen in the past, but it didn't happen as often. And so somebody was talking about planning for this, and we do have a few questions about future topics, which I know we're going to get to, so that's why I'm holding off on some of them. But this one is for Brian. If flood-prone areas are building new structures to accommodate a rising sea level, could it be possible that the water level can rise faster than they are preparing for? For instance, when Brian mentioned a construction project that is running very behind by the time they finished it, could the original estimated levels that they were prepping for be higher, thus making the project overall pointless?
Yeah, I mean, what you're talking about there is New Orleans, right? There's a lot of complexity here, but long story short, the Army Corps of Engineers has been really dedicated to trying to control flooding along the Mississippi and in the Gulf for a long time, over the course of the 20th century, right? And they built all these levees, right? And they built all these ways to sort of pump water out and in, and it worked for a while. And then the whole city got flooded in the 20s, and then they rebuilt the levees again. And then the whole city got flooded during Katrina, which that was what, 2005, maybe?
5, yeah, you're right.
And so then what they do after that, right? They rebuilt everything, rebuilt things in the floodplain. And so I think, we're already at this point where, and you guys mentioned this before, which is sort of like, how much investment are we willing to put into lost causes, right? And I love New Orleans. It's a great city. It's an iconic part of a Southern sort of culture and history, right? We don't want to lose it. But I think exactly what Alex is saying is that, what level can we prepare for, and at what point do we, cut and run, or move back a bit, or whatever the case may be. And so, yeah, these things, these pointless things happen. Yeah.
And this is actually something that the federal government is grappling with, and local and state governments are grappling with, not to get into TJ's territory too much, but sociologists there's also political sociologists, and they're really interested in what kinds of response does the government have in the face of these crushing disasters from natural disasters related to global climate change. And let me make something very clear to all of our attendees. We cannot tie any particular weather event to global climate change. But what we can say is that the likelihood of the kind of extreme weather events that we've seen, like Hurricane Katrina and Hurricane Harvey, and the droughts that have caused the wildfires out west, the likelihood of those occurring is enhanced because of global climate change. And so, the federal government and state and local governments are in the process now of trying to decide how much money do we allocate to rebuilding communities and sort of mitigating against sea level rise or flooding or whatever the disaster is. And when do we cut and run? I was just listening to a program the other day about, does the government buy out these big mansions on the coast so that they can rent them back to the owners, so that they don't have to so the government doesn't have to keep trying to keep the sea at bay, because it's so expensive to keep the sea at bay that they're trying to figure out what the alternative is. And this doesn't just affect political decision makers, it affects economic decision makers. So the insurance industry is very, very finally awakening to this problem and becoming very alert to the disasters and the cost of those disasters. Investment companies, big ones like BlackRock, are starting to turn their sights to sustainable investments because they recognize that this isn't just about, 100, 200 years from now. This is affecting their investments today. And so they need to start taking action. So when we think about this as some sort of doomsday future scenario, the doomsday is starting, but that's also the beauty of all this, I think, is because people are really alert and people in powerful decision-making positions are really alert to the problems and are starting to take action on the problems. Not all of them, not everywhere, but many in many places.
So we got
We got
really
a
good
question in the chat for you, I guess for you, TJ. Maybe.
I was just about to say that actually.
Okay, go ahead. Yeah.
Yeah, so it's sort of a general question. And as both of you were using the phrase cut and run, I immediately started thinking politically, and I was like, so I'll ask the question in a second, but I wanted to say that I think for now, if the only people being affected by rising seawater, for example, in the United States are the people who are wealthy enough to afford the houses, you're not going to have a very sympathetic audience. But when you start talking about losing cities, then the idea of cutting and running is not going to be acceptable to people. And politicians will be able to make a lot of hay out of running to protect New Orleans, running to protect Los Angeles, running to protect Miami. In the presidential election, the shift in votes around Miami took Donald Trump from barely winning Florida to winning it fairly comfortably, right? I could easily see a politician running for president in the future and saying, well, I need Miami, so I will do everything in my power. And the United States government is extremely powerful and extremely wealthy because the United States is extremely wealthy. But the question, sort of larger question around all this is seeing how there is so much scientific evidence that climate change is real. How can people in power try to say otherwise? What has made a real world problem so politicized? I'll speak to that in a second. The problem, the people denying it must be slowing down the process to make a better impact on climate change, for sure. In a democracy, in any government, everything has the potential to be politicized because everything can be something that can motivate people to turn out and vote for you, right? And so climate change, up until I'd say the last 3 or 4 or 5 years, was always something in the future, right? It wasn't really impacting our today. It was something that we're going to have to deal with in the future. And there was enough questions around causality and certainty, and are we sure? And people would harken back to in the 70s, there were scientists who said we might be heading for an ice age, right? And then in the 80s and 90s, it started becoming global warming instead. And so people could point to that and say, oh, they don't know what they're talking about. And when you're talking about problems that are that big, people have a hard time getting their heads around it, right? And I read a lot of texts from a lot of different perspectives, and I've been reading Barack Obama's autobiography from the first part of his presidency. And he tried to pass a climate change bill in his first 2 years in office. And he said one of the things they ran into, and I remember this happening at the time, was how do you convince people who are out of work, they can't afford to feed their families, right? They don't have all their ends meeting to care about the environment, right? If your regular daily life sucks, you're not going to care about the environment because that's a luxury to care about, right? Even though we know the reality of this is that it's not a luxury anymore, right? But convincing people to think about those sorts of problems was easier to politicize in the past. As the real world evidence continues to mount, that appears to be changing, especially among younger people in the United States. The evidence is growing that among younger individuals across party lines, race, gender, you name it, there's overwhelming acceptance that climate change is real. The debate about whether or not humans are causing it is sort of become secondary, right? It's happening. What do we do about it? And that's really driving sort of the vanguard forward.
I want to jump in here because I think that one of the problems that we have, though, is a recognition of this of what's happening because people don't understand science at all, right? And so Brian said earlier, I think we're all aware of this, but the reality is, based on some of the comments that people put in the chat and based on just my studies as a sociologist, people don't understand this, right? This is complicated subject matter. And one of the problems, and this is a big contributing factor to how we got here, is we have a very high level of ecological illiteracy as a species, right? We don't understand the human relationship between humans and the rest of the natural world. For much of our history, we've seen ourselves as separate from, not a part of the rest of nature, right? And that we see ourselves as a dominant species on the planet or something other than a species. Some people might even say that it's rude to call us a species. And so we have this level of ignorance or illiteracy about how dependent we are on the rest of the natural world. And it gives us this sense of that the environment can't take us down, right? That we're infallible. And we fail to recognize that if we undermine the conditions that were created, or in which we evolved, let me say, then we're going to have some problems on our hands, right? We've evolved under a certain set of conditions within the physical geography. And if we dramatically change those conditions, we can adapt culturally, but it's going to cost a lot of money. Those who can't afford it can't adapt, and other species can't adapt. And because humans don't all understand how reliant we are on the rest of the natural world, it makes it hard for people to understand all these connections.
Yeah, so I think that's an excellent point, Christine. I was thinking while you were talking, when Brian and Christine and I met to talk about this, one of the things that came up was Brian mentioned, what was that Al Gore movie?
Oh yeah, Inconvenient Truth.
And he referenced it a few times, like assuming that both of us had seen it, right, as this major point in culture for global warming and climate change. And both of us are very well educated people. We're very successful people, right? We have a lot of education under our belts. And I was like, I have not seen that film before. And Christine said, yep, I have not either. And so, yeah, I think that really hits on what, even among people with like really advanced degrees, there's sort of a limited amount of understanding. I wanted to ask one more question about the present before we switch to the future. And hopefully we wanted to end on a positive note with all this down stuff. So one question here was, are the consequences of climate change to less developed countries amplified due to a majority of those countries being in the global south, so south of the equator? How much of a difference does proximity to the equator make? Brian, what do you think?
I mean, latitude's not really aligned with risk. I would think more about elevation as a really key element of this because of sea level rise. I'm glad you clarified global south, because when I hear the phrase global south, what I think is the less developed world, right? And so that my mind immediately jumps to sub-Saharan Africa, Latin America, Southeast Asia, some of which is north of the equator. But yeah, I mean, latitude matters in terms of solar radiation, but the types of feedbacks that we're seeing here, not necessarily equatorial pattern there. To kind of follow up on this a little more though, and to talk a little more about politics, one of the ways this gets politicized and one of the ways these negotiations break down is because when you get these key emitters around the table, they point fingers at each other for a variety of different things. So the US will point their finger at China, right? And they'll say, look, you guys are emitting way more than we are right now, right? And China will look at us and they will say, do you know about residence time, Do you know how long CO2 stays in the atmosphere once it gets there? Well, up to 200 years. How long have you been emitting CO2? How long have we been emitting CO2, right? And so then it's sort of like the ball's back in our court, right? And then, you know, a place like India is sort of sitting at the table and they're saying, we can't cut emissions unless we can find another way to feed our population, right? Because we'll stop emitting when and there's a scene in one of these Al Gore films where the Indian Prime Minister Modi looks at Al Gore and says, we'll stop emitting when my people have food in their bellies. And, you know, the only response to that really is to find a way to bring a better quality of life to people that is carbon neutral somehow, right? To sort of bring them industrialization, right? Or bring them energy, or bring them HVAC, or bring them vaccines, or whatever it is, right? In some kind of way that puts them on a path that's not the one that we've been on, right? That's caused this warming. And so maybe that's a way for us to kind of transition towards kind of trends towards the future. Sort of, you know, we kind of know where we are now. So what are the kind of initiatives or projections that you all are thinking about?
I wanted to say too, sort of building off of that, from the political perspective, right? In the global South, most of those countries are run by autocracies or dictatorships, right? And so they don't have the luxury of, or those leaders don't have the luxury of constantly re-legitimizing the government through a vote. So they have to maintain their legitimacy in other more horrible ways. And one of those is to be against the West and say, the reason the West wants us to do this is because they don't want us to be as successful as them. They don't want us to be a competitor of them. It has nothing to do with the environment. They want to hold us back. And I'm a strong leader and I will push back against that. And that is a very compelling message to people who don't know any better, right?
Mhm. Sure. So in terms of solutions, there's a lot of reasons that we can be hopeful. And my thinking always is, if we have the collective will as a global community, we can solve our way out of this problem. It's not necessarily going to be easy, but we can do it. We can use cultural adaptations, such as technological innovations. And one of our attendees asked, you know, can solar panels help with this? Yes, we can use a wide array of different kinds of alternative energies to augment and eventually replace as much as possible our reliance on fossil fuels, for instance. So it's not that we'll ever be rid of our use of fossil fuels, most likely, but we can use a lot of other kinds of energy sources to replace the use of many fossil fuels, right? But we have to have the will to do that, right? And that gets into a lot of political questions that TJ could dig into. I mean, we all could, but I would let TJ do that. But there's other kinds of cultural solutions as well. So for instance, we can decide that we want to change our transportation system, right? That's a cultural solution. We can change the way we construct our homes. We can change the way we construct our cities so that they're what are deemed smart growth instead of traditional kinds of urban development. So the bottom line is there are many, many solutions in terms of both innovation, but also changing our beliefs and values and attitudes and norms and food ways that would allow us to dig ourselves out of this problem. But we have to first start out with being informed about the problem and understand the implications so that people have the will to want to make the kinds of changes that are necessary. So I was trying there to address a number of different comments from our attendees and lump them into one. So one of the things I really like to encourage you guys to understand is we don't have to get to the point of the doomsday, right? We don't have to flee the planet and establish a colony on some other planet to solve our way out of this problem, right? Humans are incredibly innovative species. We can accomplish anything we put our mind to, but we have to put our mind to doing it, right? So jump in, guys. Be more specific about some of the solutions if you'd like.
I wanted to ask about the specific things that had come up in the question, and something else we talked about before we met as well. Someone earlier asked, how much does recycling help global climate change? And would solar panels help with the rate of change as well? And something we had discussed was, if we planted a lot more trees, right? We know trees take carbon out of the air and replace it with oxygen, right? What would that help? What do you think, Brian, on those three sort of areas or other areas for the future?
Yeah, I mean, I don't know that I can put a statistic to either of those solutions, but my answer would be yes and more, right? Like we need all of those things, right? And you're actually absolutely right, TJ, right? I mean, planting forests is a big way for us to capture carbon. So there are a couple of different things we can do, right? One is we can try to remove greenhouse gases from the atmosphere, right? And so planting trees, as well as there's some pretty high tech stuff going on in places like Iceland and in Northern Europe, where they can actually pull some CO2 out of the atmosphere and store it below the surface. And I don't know if those things can be scaled up, right?
That's the problem.
But carbon capture is one component, right? Trying to figure out ways to draw it out. And then, as Christine said, trying to reduce emissions through all these different sort of technological things, right? Transitioning towards more renewable energy sources, transforming the transportation system. So put less up, take more out. And there's kind of another leg of this stool, if you will, that we haven't really talked about, which is more sort of ecological adaptation. And so I'll give an example of this. So New York City, Hurricane Sandy, for example, really opened people's eyes to the risk of sea level rise. And just like Christine said before, we don't want to attribute a single weather event, oh, that wouldn't have happened because if not for climate change. But what happens is that storm is that much stronger, those people are that much closer to sea level when the storm hits, right? And New York has had a problem with its coastline for a long time. They used to have really extensive marshlands that were anchored by oysters. They farmed out all the oysters, they dredged out the harbor, and they have nothing. They have no buffer between them and the ocean. It's city, ocean. And so they've got this long-term project to restore the marshlands around New York City. And it's pretty far along. I mean, they've been putting the oyster beds in. That allows the soil to stabilize. You can then plant coastal plants, and you get animals coming in to sort of complete the ecological habitat there. And what that does is that absorbs some of that storm surge. So does it stop the next storm? No. Does it stop climate change? But no. But it creates a situation where our civilization is better equipped to sort of dodge or minimize the impact of these kinds of things. So those are the three things I'd say, like the technical stuff, reducing emissions, the technical stuff, pulling out carbon, and then the ecological sort of restoration stuff that can make us better equipped.
Sort of building off of that, thinking about it from a political perspective, I think that ability to politicize thing is a double-edged sword, right? So it can be a bad thing. It has sort of delayed our responses to it, but it can also be a positive thing because then you can get leaders in power who will push really hard for something. And I will tell you that just knowing politics and law and the actors who go in them, carbon capture will be something that will be very compelling to them, right? Because that is the least amount of negative influence, right? And like what Brian was talking about, how rebuilding those ecosystems right off the coast, right? That is the least amount of daily impact. One of my complaints about the way a lot of environmental talk goes is that a lot of times it's, well, the only way for us to have a good future is for you to give up everything you love, right? And everything you like about your life. And plastics are so convenient, but you're gonna have to not use them at all anymore. And some of the climate change bill that Obama wanted to pass included this very complicated carbon emission balancing system where companies would be responsible for how much carbon they were releasing, and they would have to buy credits. It was a way to try to encourage them to reduce their carbon emissions. And I think that there are ways that you can do that that are less punitive to get people to reduce carbon emissions. But the most compelling thing to them will absolutely be carbon capture, for sure. As soon as the technology looks like it might possibly be scalable, they will throw endless money at it. I assure you. Like, there will be no shortage of the money to scale it up, to figure it out. And so a combination between lots more tree planting and the technology to do it. I mean, you know, Brian would know much more about the science here, but I mean, could you envision a future where, let's say we've reached that ability, right? We've planted enough trees. We have the technology to take the carbon that we put into the atmosphere, not only out, but keep it out. Would that take us back to where those normal ranges are? Of course, that puts us in a world where we're playing with the range. But anyway, that's a different nightmare for future generations to deal with.
And
Yeah,
I
I
don't mean to be a negative Nelly, but I think that it's important to realize how early we are in the stages of that particular cultural solution, right? It's an important one, and eventually we may get there, but it may not be fast enough to solve our way out of this problem, right? There's other things that we need to be doing. And I really like what one of the attendees mentioned, you know, can we be more proactive about this instead of reactive? And that is always my concern, right? We worry about solving the problem at the end of the pipeline after it's already occurred, instead of taking the initiative to deal with the problem at the front end. And I'm afraid that's sort of human nature, is we're short-sighted, right? And especially the way that our political system is structured on a 2-year or 4-year election cycle, our elected officials are focused on short-term solutions rather than long-term problems and solutions. And so it makes it really difficult for us to get to the point where we're really focused on solving the problem from its foundational points, rather than just dealing with the repercussions of the problem.
I like that you guys are kind of pointing out some of the complications here, and I really like that we don't live in an idealized world here where we want to think about what's best or what's possible, but then, you know, we're pointing out sort of what's going to be most receptive, right? What's most likely. And I think, you know, for whether it's the technical stuff, transforming the grid and transportation or whatever, TJ's right on there with, you know, you've got to make this attractive, right? It has to be about
Absolutely.
doing these things to create jobs, right? Doing these things to sort of, you know, as coal mining sort of, you know, continues to decline, right? What kinds of jobs are going to be available to those folks, right? And this is a big transition for not just the US, but other parts of the world. And I think one of the things that's most concerning for me is that, you know, in the US, we've been talking, we've been debating, we've been undermining the science, and we're losing a lot of ground. You know, the better patents and the better progress on solar and wind are coming out of Asia now, not out of the United States. And, you know, we've got the ability to sort of catch up, and we've got the ability to keep our lead in certain areas where we are in the lead. But the political and sort of cultural will on our side of the pond, so to speak, has been pretty weak comparatively.
I'll say to that, I'm sure Christine could speak to the cultural aspect of this. Americans like nothing better than a race, though, right? And so,
That's
like,
a very good point.
so being behind is a kind of a good thing for the U.S. because we're so used to being number one in so many areas. We're so used to being on top. It's easy to get complacent. But, you know, we've been complacent before. We've been behind before. I'm thinking of like the nuclear arms race during the Cold War, right? We got behind on that a few times. We were behind on the space race for a while, and we ended up on the moon first, right? Americans are competitive sort of by nature and culturally. speaking, and that is, you find that, you know, in the culture and in the government. And so, yeah, Brian is right. And I think from the perspective of that, that's a good thing for the US, because if we were ahead or there was no competition, well, then why bother? It's sort of the American way of thinking but when we're like, you mean they're trying to be better than us? No, that's a good way to get people motivated in the United States.
So we are at 1 minute to go, and I want to thank all of our participants for attending. It was fantastic to have you. As you can tell, the three of us are really, really passionate about this subject matter, and it's something that I certainly discussed a lot in class, and I'm sure that Brian and TJ do as well. So you're welcome to consider our classes if you want to dig into this more deeply. If there's topics you'd like us to discuss in future workshops like this or events like this, let us know. Thanks for being here so much. And don't forget, we have a few more social and behavioral science showcase week events tomorrow. You can also go back to the previous events if you weren't able to attend and watch them by clicking on the register for the event now or something like that. But I think those are only available right now until Friday. And then we'll have them eventually posted on our website for the department. So please don't give up hope, you guys, because there's amazing changes we can make. We just have to have the will to do it. Bye, everyone. Thank you. Is TJ gone?
Just out.
Gone.
Great job, you guys.
Yeah.
Thanks.
I really
All right.
enjoyed it. I gotta go back and watch it again, but it was really good.
Brian, that was such an amazing introduction. You really laid a great groundwork for us to all understand it
Wow.
well.
Yeah, thanks. I try to, give us in some clarity.
yeah, we
but
gotta end the
obviously
recording.
there's so much
Oh,
complexity
oh.
there.
Brian, can you stop the recording, Brian?
Oh yeah, we should have done
I
that.
stopped it. Ooh, there we go.